The TCP/IP model both defines and references a large collection of protocols. It uses documents called requests for comments, acronymized as RFCs, to reference other protocols outside of RFCs. It relies on Institute of Electrical and Electronics Engineers, IEEE, and mostly top three layers, which are application transport network layers. All these layers use requests for comments to define protocols. Layers below them, such as data link and physical layers, they rely on IEEE to define other protocols like Ethernet and 802, etc., etc. Now let's go ahead and make a clear distinction what the difference is between TCP/IP and RFC. To make a clear distinction, we can come up with an example like RFC is a type of a textbook, a book, for example, a textbook, and TCP/IP would be type of subject those books can be written about, basically, if it makes sense. Now, it's important that we understand that there are 5 layers, as we already mentioned. Let's reiterate: application, transport, network, data link, and physical. Now, each layer has its own corresponding protocols. Application layer, for example, has the biggest number of protocols. To name a few: HTTP, which stands for Hypertext Transfer Protocol, DHCP, FTP, etc., etc. Below application layer we have transport layer, and transport layer mostly utilizes TCP and UDP protocols, which stand for Transmission Control Protocol and User Datagram Protocol, and most commonly used is the TCP protocol, of course. Below transport layer we have network layer, and network layer mainly focuses on the most fundamental protocol, probably out of all, IP, which stands for Internet Protocol, and which gives us details about where the final packet, final frame should arrive, to what destination. Is it in what distance it should travel. Basically, it defines the endpoint where our final message should arrive. Now, it is worth noting that the TCP/IP on its own, it's just the name of the two of the most used protocols, which we just discussed, TCP and IP. So TCP stands for Transmission Control Protocol, which is transport layer protocol, and IP protocol, Internet Protocol, which is network layer protocol. And TCP/IP is basically just these two most commonly used protocols separated by a slash. Now, below network layer we have data link layer, and this is where our data is framed, would be a correct term to describe this process. So we have link header and link trailer, and everything between them is IP, TCP, and this data that needs to travel. And below data link we have physical layer, and which is basically cables, fiber optic cables, radio waves, electrical signals, and so on and so on. And the physical layer basically transmits bits. Now, Uh, let's elaborate on how all of this relates to computer and networking more broadly and in a way that is more understandable for the uninitiated. So on a single computer, different components implement different protocols and standards from different layers. For example, network layers, network hardware, such as the network interface card, implements physical layer protocols to support communication. When we browse the web, we're using application layer protocols like HTTP or maybe HTTPS. Now let's go into details and explain each layer in more details and how these layers are connected, and let's go step by step and define in details. Let's start with the application layer. TCP/IP application layer protocols provide services to the application software running on a computer, and as already discussed previously, we can bring as an example the HTTP protocol, which defines how web browsers can pull the contents of a web page from a web server, which is one of the most broadly used and familiar protocols out of all. In short, the application layer provides an interface between software running on a computer and the network itself. So that's the application layer. Now we get to the real meat of the matter, because we are now at the transport layer. And the two most commonly used transport layer protocols are the transmission control protocol and the user datagram protocol. And transport layer protocols provide services to the application layer protocols that reside one layer higher in the TCP/IP model. And to appreciate how really transport layer works, we have to go layer above it to the application layer and look at a small example. Basically, transmission control protocol uses error recovery. So anytime application layer tries to execute something, transmission control protocol helps this application layer protocol to make sure the data arrives, and if it doesn't arrive, it sends the error recovery message that I missed this frame, basically, or segment. Yeah. So now I hope this was more or less understandable, but it will be clearer as we continue. So now let's discuss one of the most fundamental topics of the networking regarding TCP/IP. So we have to know what same layer interaction is and the adjacent layer interaction. So the same layer interaction on different computers is when two computers use a protocol to communicate with the same layer on another computer. So the protocol defines a header that communicates what each computer wants to do. For example, the TCP process of a sender creates a header with the sequence number, and the TCP process of a receiver receives and reacts to TCP segments. So we have TCP sender and receiver, and they're both communicating on the transport layer, and they're using the same protocol, TCP protocol, to go back and forth. Now, the adjacent layer interaction on the same computer is when on a single computer, one lower layer provides a service to the layer just above, and the software or hardware that implements the higher layer requests that the next lower layer perform the needed function. And as already discussed previously, HTTP when HTTP wants error recovery, it uses transmission control protocol to perform this service of error recovery. So HTTP uses application layer uses HTTP to execute a task, and it uses transport layer transmission control protocol to make sure that the data arrives from one point to another, and if it doesn't, TCP sends error message saying that the data did not arrive. So let's go and continue to the network layer. Network layer is when we get to the IP basically. IP provides several features, and most importantly it's addressing and routing. And network layer uses the IP protocol to provide the service of forwarding IP packets from one device to another. Routers are networking devices that connect the parts of the TCP/IP network together for the purpose of forwarding IP packets to the correct destination. The internet, so we have IP address is how we send data from one place to another, and once we get to the network layer, it's when we know where our data is going basically. And to visualize this process in our head, the internet is essentially a giant mesh of routers that are connected to each other, and when we want to send data to some particular place, we need to know IP address of that router, and IP address doesn't change while our packet travels. Only MAC addresses change, because MAC addresses are changed per every hop. So once our packet leaves, it arrives at one destination, and the switch, router, whatever, it looks at the address table, and it learns where the frame needs to go next depending on the IP address and MAC address. So the next hop that our packet makes, now it's at different MAC address, but the IP address nonetheless stays always the same, because from the beginning to the end we know where we're going, but we need to know like particular steps that we have to take. So we can think of an example like a person sending a mail. So every time person sends a mail, it only writes address and sends it to the post mail or puts it in a mailbox. But the person who sends this mail does not need to know exactly what steps and how many post offices their message goes through before it arrives to final destination. And this is exactly how network and application and transport layers work. So we know where we're going, but so every time we do it, we don't need to know exactly what steps we're taking. We're just writing this message needs to go there. And once we reach the data link layer, now when the frame is finally sent out, and as already discussed previously, at each stop of a switch or router, switch once it receives this signal, it looks at the address table to decide where the frame needs to go next, if it makes sense. And yeah, and once we get past the data link layer, we arrive at physical layer. And physical layer, it just defines cabling and energy, like electrical signals or lightning pulses for the fiber optic cable, maybe that flow over cables. And physical layer moves raw bits, which are ones and zeros over a physical medium, basically.